Welcome to the deep dive. We are definitely seeing a huge transformation happening right now in how software gets made. It feels like a really profound shift.
It really is.
We seem to be moving away from, being the craftsperson hunched over the keyboard, meticulously writing every line, debugging every semicolon,
Right.
and stepping more into this role of like a product visionary, maybe an orchestrator.
That's a great way to put it, orchestrator. It's a crucial difference. We're not just getting, slightly faster tools.
No, it feels deeper than that.
It is. It's like a decoupling of our intent from the nitty-gritty implementation.
Yeah.
The focus isn't about how fast you can type or if you remember that obscure function signature anymore. It's changing our whole cognitive relationship with the code, right? Cutting down that hands-on keyboard time so we can actually focus on the bigger stuff.
Like system architecture, user needs.
Exactly. And maintaining quality, especially when things get complex,
Yeah.
high-level challenges.
And right at the heart of all this change is this idea, this term coined by Andrej Karpathy, vibe coding.
Vibe coding, yeah. It's catching on.
So today we're going deep. This is an unabridged exploration of vibe coding. Our mission really is to unpack it for you, the back-end developer listening in. What does it actually promise? Where does it really shine?
And crucially, where do you need to be super skeptical, maybe even cautious?
Absolutely. And we need to draw a clear line between this vibe coding approach and something more structured, like AI-assisted engineering. They're not the same thing.
Not at all. And Karpathy, he really nailed the essence of it when he was talking about how he uses these models. He said something like, it's like forgetting the code even exists.
Wow.
Yeah, you just describe what you need, and the AI handles the details, sometimes, thousands of lines of code.
As developers who've been in the trenches, that idea of just
Yeah.
thinking about the outcome, forgetting the code, that always felt like the dream, didn't it? The impossible dream.
Well, it's becoming reality and fast.
Yeah.
This ability, it really could unlock genuine, order of magnitude productivity gains.
Order of magnitude. That's huge.
It is. Think about it. For years, we've talked about the 10x engineer, right? That mythical person who's 10 times more productive.
Yeah, the rockstar developer myth.
But when the AI starts handling the bulk of the boilerplate, the tedious translation work,
Yeah.
that 10x starts looking more like, potentially 100x.
100x, seriously.
For specific, well-defined tasks, absolutely.
Right.
It fundamentally changes the math on what one person could potentially build or achieve.
Okay, this is big. So if we're going to really get into this shift, we need a roadmap. How are we going to tackle this today?
Good idea. Let's lay it out. First, we need to define the core concept. What is vibe coding? What does programming with intent actually mean in practice?
Right, basics.
Then we'll spend a good chunk of time mapping out what we're calling the AI coding spectrum, really contrasting that exploratory vibe approach with the more disciplined AI-assisted engineering.
Okay, the two ends of the pole.
Exactly. After that, we'll get into the nuts and bolts.
Yeah.
How does a conversation or prompt actually turn into working code? What's the mechanism?
The magic behind the curtain.
Kind of, yeah. And finally, we'll talk about the impact. What does this mean for the developer role? What skills should you, our listener, be focusing on going forward? That's crucial.
Perfect. Let's dive in.
All right.
Yeah, let's start right there, at the foundation. What exactly is vibe coding? It's definitely more than just fancy autocomplete.
Oh, way more. It's defined as a prompt-first exploratory approach to software development.
Prompt first. That's the key phrase there.
Absolutely. That's the core differentiator.
Yeah.
The whole essence of vibe coding is you describe your intent, what you want to achieve, your goal, usually in natural language, right?
It's just talking to it.
Pretty much.
Yeah.
And then you delegate all the granular implementation details, the actual coding, to a large language model, an LLM.
Which is a huge flip from how we've always done it.
Totally.
Yeah.
Historically, programming was the act of translation. You took a high-level idea, maybe from product manager or just in your head, and you painstakingly broke it down.
Into functions, loops, variables,
Yeah.
making sure the syntax was perfect so the machine wouldn't choke.
Exactly. All that detailed instruction for the machine. Vibe coding is about expressing the intent to an AI collaborator that understands, or seems to understand, that intent.
So we just talked to the machine at that higher level now, the concept level.
That's the idea. It shifts that massive, error-prone burden of translating high-level thoughts into low-level syntax, shifts it from your brain onto the AI.
Which frees up a lot of mental energy.
Huge amounts. There's this conceptual illustration often used. Maybe think of it like figure 1-1 in the source material.
Yeah.
Imagine on one side, you have the developer providing a really high-level spec, just the intent.
Okay.
And in the middle, there's the AI. Think of it as this incredibly sophisticated translator that works across multiple domains. It takes that abstract outcome-based goal,
Like build me a user login page.
right, or something even vaguer, and it instantly translates that into concrete low-level code. Could be Python, could be JavaScript, could be SQL, whatever's needed. So the developer stops thinking about writing lines of code almost entirely and focuses on providing that high-level guidance. Make it do this.
So this isn't just about coding faster then. It actually changes what it means to be a developer.
Fundamentally.
We're moving away from being just the hands-on keyboard programmer and becoming, oh, what was the term? Product engineer.
Product engineering, yeah.
Yeah.
And this is a point we really need to hammer home. The AI doesn't replace the developer. Not at all.
It actually makes the developer maybe more important, but in a different way.
Exactly. It requires the developer to move up the stack, to think at a higher level, the human element. Still the most critical factor. Why?
Because the AI can't actually think creatively.
It can't. We provide the actual creativity. We provide the comprehensive system thinking needed for, say, complex distributed back-end systems. And, maybe most importantly, we bring the empathy.
Empathy, how does that fit in?
Understanding the user. Transforming a program that just works technically into a product that people actually want to use, that solves a real-world problem effectively. That requires understanding human needs.
Yeah, no LLM is going to understand the business impact of, say, a 200 millisecond latency increase in a critical API endpoint, or the subtle compliance rules around handling user data in Europe versus the US.
Precisely. That's domain knowledge and consequence analysis. We are still absolutely essential for setting sound architecture, designing systems that are maintainable years down the line, ensuring security is baked in, not bolted on.
And let's be real, debugging the really nasty bugs.
Oh yeah, those tricky bugs, especially the state-based ones, concurrency issues. Things LLMs really struggle with because they don't run the code, they just predict it. They don't have a real runtime environment in their head.
So our new job description is .curator.editor.
Curator and editor of the AI's output.
Yeah.
That's a great way to think about it. We ensure the generated code aligns with the actual business logic, meets user needs, and hits those high standards for quality, architecture, security, performance. All the stuff that matters in the real world.
Okay, so for our listeners, the back-end developers, let's get specific.
Yeah.
Where is this AI stuff, this vibe coding, really delivering those 100x gains right now? And where do we need to put the brakes on and be super careful?
Okay, good question. The AI absolutely excels, like spectacularly, in areas dominated by well-established patterns and routine work. Anywhere speed matters more than true originality.
Like boilerplate code.
Exactly. This is fantastic news for backend folks. Setting up database models, generating standard CRUD operations, create, read, update, delete.
The bread and butter, yeah.
Writing the initial scaffolding for REST or GraphQL APIs. Generating complex integration code, like connecting service A to service B using standard protocols. The AI has seen millions of examples of connecting, say, Postgres to Kafka.
Right.
It can spit out that configuration, that boilerplate connector code, in seconds. Stuff that used to take hours of careful typing and checking documentation.
Oh man, that was the soul-crushing part sometimes, just getting the basic plumbing working.
Totally. So that's where it shines. Now, where to be cautious? You absolutely need caution when dealing with anything truly novel. New algorithms.
Things the AI hasn't seen patterns for.
Exactly. Or low-level performance tuning where you're fighting for microseconds. Or genuinely new, complex business logic that doesn't fit common patterns.
Like designing a custom consensus algorithm for a distributed system.
Perfect example.
Right.
Or a unique data compression technique. Or reasoning through the failure modes of a complex multi-step distributed transaction. The AI might generate something that looks plausible.
Looks convincing.
Very convincing. But then it could be fundamentally flawed, inefficient, or insecure in subtle ways. In those unique, complex areas, human ingenuity, deep understanding, and rigorous testing are still absolutely non-negotiable. Trying to just vibe your way through that is asking for trouble.
Okay, so this vibe coding approach, it's powerful, but has limits. And you mentioned it's kind of polarized the developer community.
It really has, which leads us to think about this as a spectrum, the AI coding spectrum.
Okay.
On one extreme, you've got this very exploratory, almost freewheeling vibe coding.
Just talk and see what happens.
Pretty much. And on the other extreme, you have a much more disciplined approach, AI-assisted engineering.
Right, we mentioned that earlier.
And this split, it really reflects Different goals, different priorities.
Hmm.
Vibe coding is optimizing almost purely for short-term velocity and exploration.
How fast can I get something working? How quickly can I test this idea?
Exactly. Whereas AI-assisted engineering, that's optimizing for sustained velocity over the long haul and, critically, for reliability.
How fast can I build something solid, maintainable, production-ready that won't fall over next year?
That's the core difference in mindset and goal.
Let's dig into that pure vibe coding end first. The code by conversation idea. The mechanism is basically using LLMs as partners, right?
Yeah.
For the heavy lifting.
Yep, leveraging them as collaborators. And it leads to that provocative idea from Jensen Huang, NVIDIA's CEO, that the hottest new programming language is English.
Because you're primarily interacting in natural language.
Right. And this conversational style, it really demands a different mindset from traditional programming.
Yeah.
You shift from careful, meticulous planning and typing
To more of an interactive back and forth, almost like brainstorming with a very fast, slightly unpredictable partner.
That's a good analogy.
Yeah.
And you see this reflected in that famous, maybe infamous quote from Karpathy about his own workflow.
Ah, yes, the accept all quote.
Right. He says, I accept all always. I don't read the diffs anymore. When I get error messages, I just copy paste them in. Sometimes the LLMs can't fix a bug, so I just work around it or ask for random changes until it goes away.
Okay, hold on. Let's pause there because I don't read the diffs anymore. Ask for random changes until it goes away. That sounds terrifying.
It does sound terrifying.
For anyone building serious back-end systems that handle money or critical infrastructure, that sounds like malpractice, frankly. How do we reconcile that statement with professional engineering?
Okay, that's the million-dollar question, and it's why we need that spectrum concept.
Mm-hmm.
That quote represents the absolute extreme edge of the vibe coding philosophy. Maximum speed, maximum iteration, minimum friction, zero immediate scrutiny.
So it's an ideal for pure exploration, not production.
Precisely. For a professional back-end developer, that accept-all mindset is only acceptable in very specific, highly constrained, non-critical contexts. Maybe you're whipping up a quick utility script just for yourself.
Or a hackathon project that just needs to work for the demo.
Exactly. Or quickly prototyping a feature just to see if the idea has legs, knowing you'll throw the code away. Outside of those narrow bounds, that level of abandoning scrutiny is, as you said, terrifyingly irresponsible for production systems.
So we should treat that quote as illustrating the potential velocity in the conversational style, but not as a literal instruction manual for building real software.
Absolutely. It highlights the philosophy of treating the AI as a conversational partner you iterate with rapidly, even blindly sometimes in exploration mode, but it's not a prescription for professional practice.
Okay, that context is critical. So this approach, even the less extreme versions, thrives because the underlying tech is getting so good, right?
Yes, there's a convergence of trends making it possible. First, the models themselves.
Yeah.
Codex, Claude, ChatGPT, the big ones, they are just astonishingly good, as the source material puts it, at generating and fixing code.
Because they've basically eaten all of GitHub.
And Stack Overflow and documentation and tutorials,
Yeah.
vast amounts of high quality and maybe some low quality code and discussion about code, they've internalized those patterns.
Okay, trend one, good models.
Trend two, new developer tools are emerging that seamlessly integrate these models right into the workflow. IDE extensions, dedicated AI coding environments.
Making it easy to just ask.
Right. Removes the friction. And trend three is the developer mindset itself is evolving. We're moving beyond just accepting simple autocomplete suggestions for the next variable name.
We're starting to trust the AI, maybe tentatively, with larger chunks of code, generating whole functions or classes.
Exactly. That growing trust, fueled by the model improvements and better tooling, enables this vibe coding approach.
And this combination leads to that 100x engineer phenomenon we talked about. Not necessarily 100x overall, but for certain tasks.
Right. We hear reports from companies seeing double, even triple-digit percentage improvements in developer velocity for specific types of work.
Like that word counter example mentioned in the source, building a simple web app.
Yeah, a tool that counts words and text, estimates reading time. The developer apparently built and deployed a functional version in literally minutes, just using high-level requests like make the stats counters break colors or add a PDF export button.
Deployed in under 10 minutes. That's wild.
It shows the power for simple, well-defined web tasks. It accelerates the trivial stuff almost to zero time cost.
And it also lowers the barrier to entry, right?
Hugely. That example of the laid-off marketer, using these AI assistants to build like 100 simple web tools.
Yeah.
And getting traction on Product Hunt.
Yeah.
That's democratizing. It fundamentally expands who can create functional software artifacts. It shortens that loop from idea to something tangible, something testable, dramatically.
Okay, the speed and accessibility are undeniable, but we keep coming back to the risks. That House of Cards scenario. If you're vibe coding rapidly, maybe not reading all the diffs, what specific back-end nightmares are you potentially building?
Oh, the list is long and scary, especially for backend. If you vibe code something critical like user login or payment processing or data handling, the initial output might work. It might pass basic tests.
What's fine on the surface?
Looks totally fine. But underneath, because the AI lacks true architectural understanding, lacks context about your specific system constraints, that House of Cards code is probably hiding time bombs.
Like what? Give me specific.
Okay, number one, security gaps. Massive ones. Missing input validation, allowing SQL injection, forgetting CSRF protection, weak password hashing, using insecure default configurations. The AI might just omit crucial defensive patterns if you didn't explicitly ask for them. Because it doesn't understand security principles, it just mimics patterns it saw.
Okay, security holes. What else?
Number two, performance minefields. Generating incredibly inefficient database queries. Maybe it forgets to add an index hint, or does a massive table scan, or creates n+1 query problems in an ORM. Fine for 10 users, catastrophic for 10,000.
Things that only show up under load.
Exactly. Or number three, system constraint violations. Generating code that uses way too much memory, or blocks the event loop in a Node.js service, or creates deadlocks in concurrent systems. It works fine in isolation on your powerful dev machine.
But falls over instantly in the resource-constrained production environment.
Precisely. Plausible, functional, but fragile. That's the House of Cards. It looks solid until the first real puff of wind load, or an attack, or an unexpected input, and the whole thing collapses.
Okay, that fragility is a perfect segue to the other end of the spectrum. The antidote, maybe? AI-assisted engineering.
That's exactly what it aims to be, an antidote to the potential chaos of pure vibe coding. The core philosophy here is totally different. It's about weaving AI capability into the entire traditional development lifecycle: design, coding, testing, documentation, but always, always under clear human control and constraints.
The human is firmly in the driver's seat.
Absolutely. The human makes the critical decisions, sets the boundaries, and owns the outcome.
And the mindset you mentioned is treating the AI like an intern.
A very fast, very knowledgeable, but ultimately junior intern. That's the key mental model.
So every single line of code the AI generates
Gets treated with the same level of skepticism, the same rigorous review as if a junior team member wrote it. For a mature engineering team building critical systems, code quality, performance, security, maintainability, these things are non-negotiable.
Right. You can't just accept all and hope for the best.
Never. You delegate the grunt work, the pattern matching, the boilerplate generation. Absolutely leverage the AI speed for that. But the human must review, reason about the implications, test thoroughly, and ultimately accept responsibility for every line that gets merged.
So the mechanism changes too. It's not prompt first anymore. It's plan first.
Plan first, or maybe spec first. You define the structure before you ask the AI to generate anything substantial.
So the developer provides a clear specification up front, like a mini design doc.
Exactly. Could be a mini product requirement document. PRD could be a detailed architectural outline. Could be just well-defined function signatures and interface contracts. Imagine, for a back-end example, you need a new API endpoint. Maybe it's complex, secured, rate-limited, handles multiple tenant contexts.
Okay.
You don't just say to the AI, build me an API endpoint. That's vibe coding. With AI-assisted engineering, you first write down the specs. This endpoint needs to use JWT authentication via this specific middleware. It must enforce a rate limit of 100 requests per minute per user using this Redis setup. The data model it interacts with is this. It needs to handle database transactions with this isolation level. Expected error codes are X, Y, and Z.
You're giving it extremely precise guardrails.
You're building the fence before letting the AI horse run. Only once that human-defined scaffolding, those constraints, are clearly articulated. Then you might ask the AI, okay, generate the handler function body based on these specs, using our standard error handling pattern.
And because the request is so specific, so well-formed,
The AI's output is much more likely to be correct, aligned with the project standards, and fit within the existing architecture. It knows which database library to use, which logging format, which security checks are mandatory. The code becomes the product of a well-formed request, not just a lucky guess from the AI.
Makes sense. It's less of a surprise generator and more of a targeted code generator.
Exactly. And this plan-first, spec-first approach is naturally favored by experienced developers, by teams working on large, complex, long-lived systems, people who prioritize robustness, maintainability, and predictability over that initial burst of raw, potentially fragile speed. They're optimizing for sustained velocity, reliable progress over time, not just instantaneous velocity. #MAVTAC Micro Recap 1.
Okay, let's take a quick breath and recap that first major section. We defined vibe coding. It's prompt first, conversational, all about exploring ideas quickly and optimizing for that initial burst of speed.
Right. The potential 100x engineer for boilerplate tasks. But, and it's a huge but, it comes with that massive risk of the House of Cards code. Looks good, works initially, but potentially riddled with hidden security, performance, or stability issues, especially for back-end systems.
And the counterpoint is AI-assisted engineering. That's spec first, plan first, much more disciplined. You treat the AI like that super fast intern.
Exactly. The human stays in control, defines the constraints, reviews everything rigorously. The goal there is sustained velocity, long-term reliability, architectural integrity, building things that last.
So maybe a simple way to think about it is vibe coding helps you figure out if you should build something. AI-assisted engineering helps you actually build it right so it can ship and scale reliably.
That's a pretty good summary of the core tension, yeah.
Yeah.
Find the path, then pave it properly.
Okay, let's shift gears now and get into the mechanics. How does this actually work? How can just describing something in English result in functional, sometimes complex code? If we're not giving explicit step-by-step instructions, what is the AI doing?
Right. This is where we see that fundamental cognitive shift we talked about earlier. We're moving away from being translators, translating our ideas into the machine's required explicit procedural steps.
We stop thinking like the compiler needs us to think.
Exactly. Instead, we're starting to express our intentions directly, what we want the outcome to be. For us as developers, this means operating at a much, much higher level of abstraction.
You used the navigation analogy earlier. Traditional coding is like giving detailed turn-by-turn directions.
Go 3 blocks, turn right at the big oak tree, look for the blue house, loop around the back, set variable, counter to 0. Very procedural.
Whereas intent-based coding is just giving the destination address.
Pretty much. Get me to 123 Main Street, safely and efficiently.
Oh.
And you let the AI, like a sophisticated GPS, figure out the best route, considering traffic, road closures, everything else.
And that abstraction is where the power comes from.
It's incredibly powerful. Your focus as a developer shifts completely. You stop sweating the low-level, had the exact syntax, the library calls, the loop structures, and you concentrate almost entirely on the what. What is the system supposed to do? What's the goal? What's the desired outcome?
Can you give a concrete back-end example of that shift?
Sure. Let's say you need a complex asynchronous process. Maybe something that needs to handle thousands of simultaneous connections, process incoming data streams according to some specific protocol, and log results or errors reliably.
Okay, traditionally that's a lot of careful work. Setting up sockets, managing buffers, writing non-blocking I/O handlers, dealing with back pressure, implementing retry logic.
Hours, maybe days, of detailed error-prone coding. You're deep in the weeds of the networking stack, the async primitives of your language.
So with intent-based programming, how does that change?
You describe the desired outcome at a higher level, something like create a non-blocking asynchronous server function that can handle up to 10,000 concurrent TCP connections. For each connection, parse the incoming data stream using Protocol X specification. If parsing is successful, write the result to the database. If it fails or the connection drops unexpectedly, log the error details, including the source IP, to an S3 bucket.
Wow, okay, so you're specifying the what? Handle connections, parse protocol, log errors, and the constraints. 10K connections, non-blocking, use S3.
Exactly. And you let the AI handle the how. Generating the specific async await code, choosing the right library for TCP handling, structuring the loops, implementing the error handling logic based on your description. Your precious mental energy is spent defining the protocol rules and the logging requirements, not wrestling with the low-level implementation details of the async runtime or the AWS SDK for S3 logging, ##3.2, the rise of the prompt, the new programming language.
So the prompt really does become the new interface, the new programming language. But it's crucial to remember, as you said, it's a description of what you want, not an instruction set telling the computer exactly how to do it step by step.
That's the core distinction. It's descriptive, not prescriptive. Instead of writing out a complex SQL query with all the selects fields, join conditions, where clauses, group by, order by.
Which can get really long and hard to read.
Right. You prompt with the description of the data you need. Write a SQL query for Postgres that joins the users table on UserID with the orders table on CustomerID. From the results, extract the email address, users.email, and the total count of orders for all users who live in California, users.state equals CA, and have placed more than 5 orders in the last 30 days. The results should be sorted by the order count in descending order.
You're describing the desired results set in English.
Exactly, and the AI translates that description into the precise SQL syntax.
And the engine that makes this possible, this translation, is the incredible progress we've seen in LLMs, the scale.
That's the game changer. The large language model is no joke. We're talking models with hundreds of billions, even trillions of parameters.
Parameters being like the knobs and dials inside the model.
Kind of. Think of them as the learned statistical configuration of the model, tuned by processing massive amounts of data, petabytes potentially. Essentially, all the public code on the internet, all the documentation, forums like Stack Overflow, mailing lists, Q&A sites.
So it's seen countless examples of descriptions and the code that follows them.
Billions and billions of examples. So when you give it a prompt, how does it actually generate the code? It's not thinking logically.
Right. No reasoning engine inside.
It's essentially playing a very sophisticated statistical prediction game. Based on your prompt, the input context, and its massive training data, it uses complex statistical patterns to infer your likely intent. Then, it predicts the most probable sequence of code tokens that should come next to fulfill that inferred intent.
Tokens being like words or pieces of words or code symbols.
Exactly. A token could be a whole word like function, or part of a word like config, or a symbol like or vigor, or a variable name like user I. The model generates the output one token at a time, choosing the token that has the highest probability of being correct, given the preceding tokens and the initial prompt.
Okay, this is really important for our listeners, especially back-end devs, to get. The model is not thinking. It's not running the code as it writes it. It doesn't have a built-in compiler or runtime environment checking for logical correctness or type safety.
That is the absolute critical technical detail. That lack of an internal runtime, that lack of true understanding, is its Achilles heel. Because it means the LLM can generate code that looks perfectly plausible, so technically correct, uses the right keywords, follows common patterns, seems utterly convincing.
But is subtly wrong.
Subtly or catastrophically wrong. It might contain logical flaws, it might have performance issues, or, and this is a big one, it might suffer from hallucinations.
Hallucinations, like making things up.
Really much.
Yeah.
Because it's just predicting statistically likely sequences, it might confidently generate code that calls a library function that doesn't actually exist, or references an API endpoint with parameters that are incorrect for the version you're using, or uses a configuration setting that's been deprecated. It sounds right, looks right based on patterns it saw, but it's factually incorrect in your specific context.
And only rigorous human review and actual testing can catch that. The AI itself won't know it hallucinated.
Exactly. It has no self-awareness of correctness. It just generates the most probable next token. Hashtag 3.3. The iterative cycle. Collaborative feedback loop.
Okay, so if the LLM can generate plausible but wrong code, and it doesn't know when it's wrong, then just prompting once and accepting the output is clearly not the way to build reliable systems.
Absolutely not. Which brings us back to the idea that intent-based programming, especially for anything important, must be an iterative, collaborative process, a conversation, a feedback loop between the human and the AI.
But code generation is just one step in a longer dance.
Exactly. The key insight here is that getting that initial chunk of AI-generated code is maybe only step 2 in what's really a 6-step cycle. This iterative cycle is how we inject human expertise, testing, and context to harden that statistically generated code into something trustworthy.
Okay, let's walk through that 6-step algorithm. Let's use a concrete backend scenario again, maybe generating, say, a database migration script. Those can be tricky.
Good example. Okay, step 1, describe. You start the conversation. Your initial prompt might be something high level. Generate a Python script using the Alembic library to add a new non-nullable created at timestamp column with a default value of the current time to the products table in our PostgreSQL database.
Okay, pretty clear intent.
Step 2, initial solution. The AI generates the Python script. It probably includes the Alembic op-ed add column command, maybe some basic import.
That's plausible.
Step 3, review and test. Now the human steps in. You carefully review the generated Python code. Does it handle the non-nullable constraint correctly for existing rows? Does it set the default value correctly, using server default for database efficiency? Does it include the corresponding downgrade function to make the migration reversible?
Critical for migrations.
Absolutely.
Yeah.
And you'd mentally, or actually test edge cases. What if the table's huge? Will adding a non-nullable column with a default lock the table for too long? Maybe you realize the AI didn't specify the server default properly, or it forgot the downgrade path.
Okay, found some issues.
Step 4, refine request code. Based on your review, you provide specific corrective feedback. You prompt the AI again, modify the script. Ensure the created column uses server default func.now for the default value. Also, add the corresponding opti.drop column command in the downgrade function. Or you might just manually edit the generated code yourself to fix the server default because it's quicker.
So you guide it or fix it directly.
Right. Step 5, AI refines. The AI takes your feedback or observes your edit if the tool supports that and updates the code, hopefully correcting the default value mechanism and adding the downgrade step.
Getting closer.
Step 6, repeat as needed. You review again, maybe now it looks correct, but you realize you also need to add an index on this new timestamp column for common queries. So you prompt again. Now, add a non-unique index to the created column in the same migration. You continue this loop. Describe, solution, review, refine, solution. Repeat until the code is not just functional, but robust, efficient, and correct, according to your expert judgment.
It really emphasizes the collaboration aspect. It's not fire and forget.
Not at all. And the mindset here is exploration and refinement. Because the AI generates the initial draft so quickly, the cost of a false start, getting code that's not quite right, is incredibly low compared to traditional coding, where you might have spent hours writing that initial draft yourself.
Yeah, throwing away AI code feels cheap. Throwing away your own code hurts.
Exactly. So it encourages experimentation. Try an approach, see what the AI gives you, refine it, maybe ask the AI to try a different approach entirely.
Yeah.
It's a much more fluid and less psychologically costly way to evolve a solution.
Okay, so we understand the mechanics now, the prompting, the token prediction, the crucial iterative cycle. Let's talk about the broader impact. This shift towards intent-based programming, what are the real-world consequences for the software industry, especially looking at productivity, hashtag TagTag 4.1, boosting productivity, the 100x reality?
Well, the first and most obvious impact is that productivity boost we keep mentioning. The sheer speed at which AI can automate the rote, repetitive work is genuinely transformative.
We talked about boilerplate.
Right. For back-end tasks, setting up data models, writing data cleaning or transformation scripts, scaffolding out basic API endpoints, writing configuration files for infrastructure, tasks that used to eat up hours, sometimes days, of meticulous, frankly boring, low cognitive load typing.
Can now potentially be done in minutes.
Literally minutes in many cases. And those early studies we mentioned are backing this up, consistently seeing double, even triple-digit percentage speed increases for developers using these tools effectively for the right kinds of tasks.
But you hinted earlier that the real productivity gain isn't just raw speed of typing, it's something more cognitive.
Absolutely. Think about the mental cost of context switching. When you're deep in writing boilerplate code, you're forced to load the specific syntax rules, the library conventions, the intricate details of that particular framework into your working memory.
Yeah, your brain is occupied with low-level details.
Exactly. By offloading, say, 80% of that routine code generation to the AI, the developer's brain is freed from that constant low-level context churn, that mental energy, that precious cognitive bandwidth.
That used to be spent remembering the exact arguments for, I don't know, setting up an express middleware function.
Right. That energy can now be redirected to higher value problems. Optimizing a complex database query strategy, designing a more resilient system architecture, thinking through edge cases and the business logic, brainstorming innovative new features. The AI handles the tedious execution. The human focuses on strategy and design. That's a massive leverage point for productivity. Hashtag TagTag 4.2.
Lowering the barrier to entry, accessibility.
Okay, so faster, more focused developers. The other big impact seems to be accessibility, making development possible for more people.
Definitely. By shifting the primary burden of remembering exacting programming grammar and syntax from the human to the AI, it dramatically lowers the barrier to entry.
You don't have to spend months just mastering the syntax of Java or Python before you can build something useful.
The ramp-up time gets significantly shorter, especially for people who are already domain experts in another field but aren't professional programmers. Think about a biologist who understands complex genomic data analysis workflows.
Traditionally, they'd need to either learn complex bioinformatics programming tools or try to explain their needs perfectly to a software engineer. Now, it's becoming conceivable that they could directly describe the data processing steps they need in fairly natural language.
And get the AI to generate a functional Python script with the right libraries, like Pandas or BioPython, to actually perform that analysis.
Exactly. It might not be perfect, production-ready code, but it could be a functional prototype, something that produces results they can work with immediately. It compresses that journey from domain knowledge to tangible, functional software dramatically.
That's incredibly exciting. But it does raise that question again. If biologists and marketers can suddenly generate functional code, does that devalue the skills of trained software engineers? What happens to junior developer roles, for instance?
It's a valid concern, but I think it shifts the value proposition. It doesn't eliminate it. The value moves up the stack. It shifts from the ability to write syntactically perfect code from scratch
To the ability to specify intent clearly and critically to validate the AI's output.
precisely. While a non-coder might be able to generate a tool that seems to work, that tool almost always needs professional engineering oversight to make it robust, scalable, secure, maintainable, ready for real-world use.
So the junior dev's job isn't necessarily writing basic CRUD apps from scratch anymore.
Maybe less so. Their role might evolve into take the AI-generated first draft of that CRD app, which was created in minutes, and then apply rigorous testing, integrate it correctly with the existing system, ensure it meets security standards, optimize the database interactions, and basically harden it for production. They're focusing on architectural fit, testing rigor, and system integration, maybe even earlier in their careers. The entry point shifts, but the need for engineering discipline remains, perhaps even grows.
Okay, so if the AI is handling that routine 80% of the coding effort, freeing up our time and cognitive load, where should we, as human developers, be directing that newfound mental energy? What's the highest leverage use of our skills now?
It has to be on that remaining 20%.
Yeah.
Hard stuff, the inventive stuff, the uniquely human stuff.
Like what specifically?
Tackling truly novel algorithms where no existing pattern applies. Designing the long-term architecture for scalability and resilience thinking years ahead. Reasoning through complex failure modes in distributed systems, something AI is still very weak at.
And the user-facing aspects.
That absolutely. Focusing deeply on user experience. Understanding the nuances of user needs and translating that into elegant, intuitive interfaces and workflows. That requires empathy, creativity, strategic thinking capabilities that are, for now at least, firmly in the human domain. The AI becomes the incredibly fast engine for execution. The human provides the strategic direction, the architectural vision, and the creative spark.
We've touched on the house of cards danger, but let's really focus on the challenges now, especially for back-end developers where mistakes can be incredibly costly: data loss, security breaches, system outages. The challenge of trust and correctness feels enormous.
It is. It's probably the biggest hurdle to widespread, uncritical adoption. The AI's ability to generate plausible-sounding but incorrect code is deeply problematic.
Deceptively plausible.
Exactly. It might generate, say, a complex database migration script involving multiple steps, maybe data backfilling.
Yeah.
And it looks perfect. It follows all the right conventions.
Passes a basic code review, maybe.
Could easily pass a quick review. But maybe it contains a subtle race condition that only manifests under heavy load. Or it violates a crucial foreign key constraint only when dealing with a specific edge case in the existing data. Or it uses a function that has slightly different transactional semantics in version X of the database versus version Y.
Things that only bite you later in staging, or worse, in production.
Right. The AI, being a statistical model, lacks the deep causal understanding of the system constraints, the data integrity rules, the specific runtime environment. That understanding, that reasoning must come from the human developer performing rigorous validation and testing. We have to provide the context the AI lacks.
Okay, trust and correctness, a huge challenge. What about the other big one? Skill atrophy. If developers, especially junior ones, aren't wrestling with the low-level details anymore because the AI handles it, do they ever build the fundamental knowledge?
This is a massive concern, and it potentially strikes at the very core of developing deep back-end expertise. If you always rely on AI to generate your database schemas and ORM models,
Do you ever truly internalize the principles of database normalization? Why third normal form matters for data integrity and avoiding redundancy?
Exactly. Or if the AI always generates the boilerplate for asynchronous code and concurrency control. Do you develop the intuition needed to reason about complex deadlocks, race conditions, or the nuances of different locking strategies when the AI's first attempt fails?
Or understanding the real performance cost of network calls between microservices. If the AI just generates the gRPC client and server code, do you miss learning why making dozens of small calls in a loop is a recipe for disaster in a distributed system?
Precisely. That struggle, that pain of debugging a tricky concurrency bug or optimizing a slow query by hand, that's where deep learning and intuition often come from. If developers are shielded from that struggle too early or too completely.
They risked becoming dependent, unable to effectively debug, maintain, or significantly refactor the code the AI generated once it gets really complex, or when the AI inevitably gets stuck on the hardest 20–30% of the problem.
That's the fear. We risk creating a generation of developers who are expert prompt engineers and code curators, but perhaps lack the foundational architectural understanding and debugging skills needed to build truly robust, resilient, high-performance systems from the ground up, or to fix them when they inevitably break in complex ways. It's a serious pedagogical and long-term capability challenge for the industry. Hashtag #MicroRecap 2.
Okay, let's do another quick recap. We've covered the mechanics. The LM engine predicts code token by token based on probability, not logic. It doesn't compile or run the code, hence the risk of plausible errors and hallucinations.
Right. And the necessary antidote is that iterative, six-step collaborative cycle. Describe, get a solution, review rigorously, refine the requester code, let the AI refine the solution, and repeat until correct. It's a conversation, not a command.
The impact is potentially huge, that 100x productivity on routine tasks, lowering the barrier to entry. But it shifts the human focus.
Shifts it squarely onto the hard 20%. Architectural judgment, system design, creative problem solving, user empathy, and crucially, fighting that house of cards tendency of AI code by maintaining rigorous standards.
And we have to actively address the challenge of skill atrophy, ensuring developers, especially juniors, still build that deep, hard-won intuition about how systems actually work under the hood, particularly for complex back-end concerns like databases, concurrency, and distributed systems. We can't afford to become just curators who don't understand the fundamentals.
Well said. That balance is key.
So we've painted these two pictures: the fast, exploratory vibe coder and the careful, disciplined AI-assisted engineer. But you emphasized earlier, these aren't rigid categories, right? They're ends of a spectrum.
Absolutely critical point. They are not mutually exclusive boxes you have to choose between. In the real world, effective, mature development workflows will almost certainly blend techniques from both ends of that spectrum.
So the modern developer needs to be comfortable moving between those modes.
Exactly. Think of it like having different tools or maybe different vehicles. Vibe coding is like your high-speed, maybe slightly reckless exploratory vehicle. A dune buggy, perhaps.
Okay, I like that. Great for quickly scouting new terrain.
Perfect for hackathons,
Okay.
for quickly testing the feasibility of a new idea, for rapidly exploring a new library or API to just see what it can do. High speed, high agility, maybe not built for a long, safe journey.
And AI-assisted engineering is the reliable train.
Yeah, I like that metaphor too. The reliable train running on a well-planned track. It requires upfront work. You have to lay the tracks carefully, write the specs, define the architecture.
More planning, slower start maybe.
Slower initial start, definitely. But it's far safer, more predictable, and the only viable way to transport valuable cargo your production application reliably over long distances, ensuring it arrives intact and on schedule, and can keep running for years. Experienced developers intuitively learn when to hop in the dune buggy for quick exploration and when to board the train for serious construction.
It's interesting to think about how developers might evolve in their use of these tools. Does one typically lead to the other?
We're seeing anecdotal evidence that suggests a pattern. Often when developers first encounter these powerful AI tools, there's an alluring novelty phase. The sheer magic of talking a complex function or even a whole database schema into existence with just a few prompts, it's incredibly compelling.
Pure vibe coding feels powerful initially.
Very powerful, very exciting, like getting superpowers. But often after the initial honeymoon phase, maybe after the first time a purely vibe-coded system fails a security review or hits an unexpected scaling wall or becomes impossible to debug.
Reality bites.
Reality bites hard. Pragmatism sets in. Developers naturally start shifting towards the more disciplined, AI-assisted end of the spectrum for serious work. They realize the value isn't just in generating any code quickly, but in generating the right code, constrained code, code that fits the larger system.
So they move from just prompting vaguely
to breaking down problems into smaller, more manageable pieces, feeding the AI highly specific, well-constrained requests rather than asking it to generate the entire application in one go. They transition, as we said earlier, from being prompt artists, trying to coax magic out of the machine.
To becoming AI orchestra conductors.
Exactly. Skillfully guiding the immense power of the AI, the orchestra, with a deliberate, knowledgeable hand, the conductor's baton, ensuring each section, each generated piece of code, plays its part correctly, harmoniously, within the context of the entire composition, the overall system architecture.
And the tooling itself seems to be evolving to support this blend, right? It's not just one type of tool.
That's right. The tooling landscape is rapidly maturing to support the entire spectrum. On the vibe coding end, you see specialized tools, often chat-based interfaces like Cursor, or experimental platforms like Windsurf mentioned in the source, that really lean into that natural language interaction and rapid iterative generation.
Optimized for conversation.
Right. And on the AI-assisted engineering end, you see the mainstream professional IDEs, VS Code, IntelliJ, etc., deeply integrating AI features in a way that respects the traditional structured workflow.
Like AI-powered linters that suggest fixes.
Exactly. Or sophisticated code completion that understands your project context. AI-powered documentation generators that work from your code and comments. Even AI bots integrated into version control that can review pull requests for common issues or suggest refactorings. These tools augment the engineer's existing process rather than completely replacing it with a chat window.
So the ideal future isn't choosing one end of the spectrum, but being able to fluidly move along it.
That feels like the optimal state. Having the skill and the tooling to start with a burst of high-speed creative vibe coding during the initial ideation or prototyping phase, explore possibilities rapidly.
Get something rough working quickly.
Right. But then having the discipline and the tools to instantly switch gears, to rein that initial exploration in, apply rigorous AI-assisted engineering practices, detailed specs, careful review, thorough testing when it's time to actually harden the solution, ensure its quality, and ship software that absolutely must be reliable and maintainable, moving effortlessly up and down that spectrum as the task demands.
Okay, we've covered a massive amount of ground in this deep dive into Chapter 1. Let's try to synthesize the absolute core takeaways. The central argument really seems to be that the value proposition for us as developers is shifting. It's becoming less about our typing speed or our ability to perfectly recall syntax.
And much more about our ability to clearly articulate intent, to provide high-level guidance, and to critically evaluate and shape the output of our AI collaborators. Our value is moving up the abstraction ladder.
So, to help everyone listening lock in these key ideas, let's run through them almost like flashcards. Core concepts from today's discussion.
Okay, first, vibe coding. Remember, that's prompt first, highly exploratory, optimized for short-term velocity and discovery. Think dune buggy.
Next, AI-assisted engineering. That's spec first, plan first, highly disciplined, optimizes for sustained velocity, long-term reliability, and robustness. Think train on a track.
Then there's the 100x engineer. Not necessarily literal, but represents that potential order of magnitude productivity gain, especially by leveraging AI to automate the heavy lifting of boilerplate code, CRUD apps, basic integrations.
Crucial concept. Programming with intent. This is the fundamental shift, focusing on what the desired outcome, the goal, rather than painstakingly specifying the step-by-step implementation details.
Don't forget the LLM mechanism. How does it work? It generates code by predicting the statistically most likely next token based on patterns learned from vast training data. Critically, it does not think, reason logically, or compile or run the code internally. That's why it can hallucinate or make subtle errors.
Which leads to the iterative cycle, that essential 6-step collaborative process. Describe initial solution, review and test, refine, request code, AI refines solution, repeat. It's a feedback loop, a conversation.
And finally, the human domain. What remains uniquely human and arguably becomes even more valuable. System thinking, strategic architectural design, debugging the truly complex and novel bugs, especially concurrency, creativity, and deep user empathy.
That feels like a solid summary of the core pillars of this first chapter. It really paints a picture of a changing landscape.
It absolutely does. The takeaway really is that programming is rapidly becoming less about the mechanics of forcing ourselves to think like a machine, breaking everything down into explicit logical steps the computer can follow.
And more about leveraging our uniquely human strengths. Creativity, judgment, system understanding, architectural foresight, to effectively direct the machine, which is becoming increasingly capable of understanding our intent. #tag outro. That shift leaves us with a really interesting, maybe even provocative thought to mull over. What happens to the entire pipeline of software development education, how we teach computer science fundamentals, data structures, algorithms, when the machines we're programming become capable of understanding what we want them to achieve, not just executing what we explicitly tell them to do step by step?
It fundamentally challenges the traditional definition of programming literacy, doesn't it? What does it mean to know how to code in that future?
It's a deep question.
Definitely something to think about.
So we've thoroughly defined the landscape of vibe coding versus AI-assisted engineering in this deep dive. We understand the concepts, the mechanics, the pros, the cons. Where do we go next?
Our next step is to get practical. Now that we understand the what and why, we need to learn the how. Chapter 2 is all about the art of the prompt. Right. How to actually talk to these AI models effectively. How do you structure your requests, provide context, guide the refinement process to get the best possible results code that's not just fast, but also accurate, efficient, and architecturally sound.
Exactly. We'll dive into the specific techniques for crafting prompts that work.
Looking forward to that.
So for you, our listener, the backend developer tuning in, as you go back to your code editor today, maybe pause and think about your own workflow. Where do you currently sit on that spectrum between vibe coding and AI-assisted engineering? Are you leaning more towards the rapid exploration or the disciplined construction? And perhaps more importantly, are you ready to consciously start practicing the skills needed to become that AI orchestra conductor?
It's the key question for navigating this transition.
Thank you for joining us for this deep dive.